When the B-52 first took flight in 1952, few could have predicted that this bomber would not only outlast the Cold War, but also remain a cornerstone of US air power well into the 21st century. Now, more than 70 years later, it continues to serve as a critical asset, undergoing yet another round of modernization to extend its combat effectiveness for decades to come. But how did a mid-20th century turboprop concept evolve into an enduring symbol of strategic dominance? Like many of America's most iconic military aircraft, the B-52 was born out of the urgent need to counter the growing Soviet threat. The selection of a manufacturer for the US Air Force's next-generation nuclear bomber was almost inevitable. By the end of World War II, Boeing had cemented its reputation with the legendary B-17 Flying Fortress, which had proven its effectiveness in both the Pacific and European theaters. As the company was finalizing production of nearly 4,000 B-29 Superfortresses in November 1945, the Air Materiel Command laid out its requirements for a new long-range bomber to replace the aging Convair B-36 Peacemaker. Design requirements and the debate over propulsion. The initial specifications for the new bomber included a crew of at least 5, including turret gunners and a 6-man relief crew, a maximum airspeed of 300 miles per hour at an altitude of 34,000 feet, a combat radius of 5,000 miles, armament consisting of 20mm cannons, and a payload capacity of 10,000 pounds of various munitions. However, within months, performance demands grew significantly. The required speed was increased to 400 miles per hour. The operational range was extended to 12,000 miles, and the bomber was now expected to carry nuclear weapons, cementing its role in America's strategic deterrence. One of the most contentious issues in the development process was the choice of propulsion. Military planners were divided between turboprop and turbojet engines. At the time, early jet engines were notorious for their high fuel consumption, leading the Air Force to instruct Boeing to fit one of the first B-52 prototypes, the 46440, with turboprop engines instead of the originally planned Westinghouse Joule 40 turbojets. This decision sparked heated debates within military leadership. General Howard A. Craig, Deputy Chief of Staff for Materiel, was skeptical of using jet propulsion, arguing that the technology was not yet mature enough to justify bypassing the turboprop stage. Conversely, General Curtis LeMay, Deputy Chief of Air Staff for Research and Development, strongly advocated for turbojet engines. He believed that range limitations could be addressed later through airframe refinements and insisted on switching from a tandem cockpit layout, similar to the Boeing B-47 Stratojet, to a side-by-side configuration. This, he argued, would reduce pilot fatigue and enhance crew coordination during extended missions. Refining the B-52 from hobby store materials to global dominance. After extensive debates and refinements, the final design requirements for the aircraft settled on a top speed of 500 miles per hour and a flight range of 8,000 miles. However, one of the most remarkable moments in the Stratofortress's development came toward the end of its design phase. A group of Boeing engineers, George S. Scherer, Art Carlson, von Blumenthal, Maynard Pennell, Bob Whittington, and Vice President of Engineering Ed Wells, took an unconventional approach. Gathering supplies from a local hobby store, they worked in a garage-style setting at the Van Cleve Hotel in Dayton, Ohio, where they constructed the B-52's prototype model. The design was based on the proven layout of the B-47 Stratojet, featuring 35-degree swept wings, 8 turbojet engines mounted in 4 twin-engine nacelles beneath the wings, and a bicycle-style landing gear with outrigger wheels at the wingtips. The result of that weekend in Dayton was a sleek, subsonic aircraft with an optimal aerodynamic profile. Built from balsa wood and painted silver, the model impressed military officials, securing the B-52's transition into full-scale production. The first prototype of the B-52 took to the skies in April 1952, just 3 years after the Soviet Union successfully detonated its first atomic bomb. By June 1955, the bomber had officially entered service with the 93rd Heavy Bombardment Wing at Castle Air Force Base, California. Then, in January 1957, 3 B-52s from the U.S. Air Force completed Operation Power Flight, a historic, non-stop, around-the-world journey. Flying at an average speed of 525 miles per hour, the bombers covered the entire globe in just 45 hours and 19 minutes, proving the aircraft's unmatched endurance and cementing its place in history. This was far from the B-52's final record. In the years that followed, the bomber continued to push the limits of aviation endurance, setting milestones such as a 12,532-mile non-stop flight without refueling from Kadena Air Base in Okinawa, Japan, to Torrejon Air Base in Spain. Today, the B-52H remains the only variant of the Stratofortress still in active service with the U.S. Air Force. Derived from the B-52G, it retains the same fundamental airframe, but incorporates a significant power plant upgrade, Pratt & Whitney TF33 P-3 turbofan engines. While the engines initially faced reliability issues, these were successfully resolved by 1964 under the Hot Fan program. The new engines vastly improved the bomber's performance and efficiency compared to its predecessor, which used Pratt & Whitney J57 turbojets. With this upgrade, the B-52's top speed increased to 650 miles per hour. Its cruise speed improved to 509 miles per hour, and its maximum range without refueling expanded to 8,800 miles. Beyond engine enhancements, the B-52H also received several key upgrades. A new tail turret, fitted with a 20mm M61A1 Vulcan rotary cannon. An advanced avionics suite optimized for low-altitude penetration, including a terrain-following radar, ACR, for enhanced navigation, a modernized fire control system for improved combat capability. These upgrades ensured the B-52H remained a dominant force in strategic bombing, reinforcing its status as one of the most enduring and formidable aircraft in military history. The enduring legacy of the Buff. The U.S. Air Force continues to rely on the B-52 Stratofortress, affectionately known as the Buff, as it remains the most cost-effective and mission-capable heavy bomber, particularly when facing adversaries with limited air defense capabilities. In post-Cold War conflicts, such as Operation Iraqi Freedom, the B-52 played a pivotal role in supporting ground forces, proving its continued relevance in modern warfare. Beyond its combat versatility, the B-52 boasts the highest mission readiness rate among all heavy bombers in the U.S. Air Force fleet. During the 2000 to 2001 period, the average readiness rates of its counterparts were Rockwell B-1 Lancer, 53.7% Northrop B, 2 Spirit stealth bomber, 30.3% Boeing, B-52, Stratofortress, 80.5%. However, even a warhorse like the B-52 requires modernization to remain effective. Recognizing this need, the U.S. Air Force launched the Commercial Engine Re-engining Program, CERP, in April 2020, seeking 608 new commercial engines to extend the aircraft's lifespan. Major aerospace firms competed for the contract. General Electric, CF3410, and Passport turbofan engines Pratt & Whitney, PW800 Rolls-Royce, BR725, military designation, F-130. By September 2021, the Air Force selected Rolls-Royce's F-130, awarding a $2.6 billion contract for 650 engines. While some industry experts advocated replacing the B-52's 8 engines with 4, critics argued that such a shift would require an extensive redesign of the airframe and flight controls, an expensive and complex overhaul that the Air Force sought to avoid. Another groundbreaking upgrade will be the installation of the ANAPG-79B4 AESA radar in the upcoming B-52J variant, replacing its outdated mechanically scanned array. This advanced radar system will significantly enhance the bomber's range, targeting accuracy and resistance to enemy countermeasures, ensuring its effectiveness well into the future. Despite its age, the B-52 remains an irreplaceable pillar of U.S. strategic air power. The question now is, could this Cold War giant outlive the younger B-2 Spirit and the next-generation B-21 Raider, reclaiming its dominance in the nuclear triad?